Hi all, today's topic is covariance for a continuous random variable. Two-dimensional random variable x and y have a joint density function f of x comma y is given in the question 2 minus x minus y. Limit is given, x limit is 0 to 1, y limit is 0 to 1. Find covariance. We know that covariance, the formula for covariance is nothing but E of xy minus E of x E of y. Same way, E of x we know the formula to be single integral over x into f of x dx. E of y is integral over y into f of y dy. E of xy is double integration over f of x comma y dx dy. And same way f of x first we need to calculate. It's nothing but marginal density function for x. Same way marginal density function for y, f of y. F of x is integral over y, f of x comma y dy. We know that y limit, what it is, y limit 0 to 1. So we'll do now 0 to 1, 0 to 1, 0 to 1. F of x comma y given in the question 2 minus x minus y into dy. So integrate it with respect to dy, we integrate it 2y minus xy minus y square divided by 2. Substitute your upper limit and lower limit. So only we have to substitute it for y. So it is 2 minus x as it is minus 1 by 2. Take LCM, this both and this both take LCM. 2 minus 1 by 2, 4 by 3, 4 minus 1, 4 minus 1. So 2 minus 1 by 2, it's nothing but 4 minus 1, 3. So 3 by 2. So 3 by 2 minus x. So our f of x is 3 by 2 minus x. Same way f of y I need to calculate. Same concept. So integral 0 to 1. So 2 minus x minus y into dx. So integrate it with respect to x. So 2x minus x square divided by 2 minus xy. Integral 0 to 1. So when I substitute only for x, I have to substitute. So 2 minus 1 by 2 minus y. Okay, so it is nothing but same 4 minus 1, 3. So 3 by 2 minus y. So our f of y is 3 by 2 minus y. So completed. Now everything we have to substitute in this. Find e of x, e of y and e of xy. All the three parameter I need to calculate. So we'll calculate first. So first e of x I will do it. Single integral over x into f of x dx. So it's nothing but limit, we know that it is 0 to 1, x as it is, f of x is 3 by 2 minus x dx. Multiply x inside. So it's nothing but 3x square divided by 4 minus x cube by 3. So 0 to 1. So when I substitute it, 3 by 4 minus 1 by 3. So 12 when I take LCM. So 9 minus 4, 5. So 5 by 12 is our answer. Same e of y. Single integral or y, f of y dy. So integral over 0 to 1, y into 3 by 2 minus y into dy. So substitute here y, take it inside, then only integrate it. Now 3y square divided by 4 minus y cube divided by 3. So 0 to 1, same solution only. So 5 by 12. So completed. E of xy have to do. E of xy when we do it. double integration over x y into f of x comma y. So it is given in the question 2 minus x minus y to dx dy. So both are limit 0 to 1. So x, y I will multiply inside. Multiply. Now differentiate with respect to x first, then y. Any order, our wish only. So it is 0 to 1. With respect to x first, I will do it. When I do it, dy as it is. Okay. So I'll be getting 0 to 1. So x only I have to put 1. So y minus x I have to put 1. So y by 3 minus x I have to put 1. So y squared by 2 into dy. So again one more time with respect to y, integrate it. So when I integrate it, so y squared by 2 minus y squared by 2, 6 minus y cube by 6, 0 to 1. So when I substitute it, so 1 by 2 minus 2 by 6. So take LCM, 6 LCM you take. So 3 minus 2. So I'll be getting 1 by 6. E of xy is 1 by 6. Now substitute all the answer in the covariance. We will get our covariance. So when I substitute it, covariance of x comma y equal to, so when I substitute, it is 1 by 6 minus 5 by 12 into 5 by 12. So it is 144 when I take LCM. So 24 minus 25. So minus 1 by 144. So our covariance answer is covariance of x comma y equal to minus 1 by 144. So completed. I will do one more problem in this topic, covariance. This is our last topic in the covariance, problem 3. It is not to be a discrete, not to be a continuous, okay, but a different way. Covariance, it can be asked like this also. So what is the question means? If the independent random variable x and y have variances 36 and 16 respectively, find covariance. And find the covariance of x plus y and x minus y. If the question is given like this, how we have to do it? Okay. So now, first step, we know that if x and y are independent, if two variables are independent, okay, two variants are independent. It is given in the question x and y are independent. X and y are independent means we know that covariance is 0. Covariance of corresponding x and y only 0. Okay, so it is given in the question covariance is 0. But they asked the covariance of this, okay, change of parameter, okay. So that only it is asked. It is given in the question variance, two variances. So it is nothing but sigma x squared, it is given to be 36. Sigma y squared, it is given in the question 16. we have to find the covariance of this. How can I find it? First, we have to convert the given question. First question to u and second question to v. X plus y, I am going to change it to be u, and x minus y equal to, I am changing the variable to v. I can do it. I can change and do it. This already I told in the covariance when I gave the problem, okay, properties of covariance. In that I mentioned when I change the origin and scale, it will not affect, okay, it will not affect at all. The question will not be affected. Now covariance of u comma v only it is asked to find. For finding this, covariance of u is nothing but x plus y, v is nothing but x minus y. So this is the property. How can I write? When it is x plus some variable and x minus some variable, means how can I write? Means using the property. So it is a property. Write it in full form. What is that property? So what is that property? Means if covariance of x plus some a, covariance of x minus some b, means how can I write? Means covariance of x plus, okay, so this x I can write, or you have a confusion, means I will use this to be y, so that it is easy for you to understand. Like this, x plus a and y minus b if it is, okay, how can I write? Means first I have to write x plus a as it is, comma, the first term, this first term I have to write y minus of covariance of x plus a as it is, okay, the second term, okay, b. So this is the first property, one of the property that I am going to use in this. So if I use, it's nothing but covariance of same concept when I write x plus y comma x minus of covariance of x plus y comma y. Okay, completed. Still it is not completed. I have to again expand this and write. Okay, this I can write. Okay. So x plus y comma x, I have to write it. Now when I write this, for this property again I am going to use the property. This is property. Is covariance of x plus y comma some x. How I have to write it? Means covariance of first variable comma the second, plus covariance of second variable, the first variable comma second variable. Okay, this way only I have to write it. Okay, now when I write it, extend it, covariance of x comma x plus covariance of x comma y minus covariance of x comma y minus covariance of y comma y. So completed. Now as per the property I have written, we know that covariance of x comma y is 0. Okay, wow. Covariance of x comma y is 0. So that both are 0. Okay. So again any other term it is 0. Covariance of x comma x is nothing but, we know that it is nothing but variance of x. Okay, both are same, it is a variance of x. This is nothing but variance of y. So it is variance of x is nothing but sigma x squared minus of sigma y squared. This both given in the data, it's nothing but 36 minus 16. So equal to 20. So covariance of whatever the question it is asked u comma v is our answer is 20. Complete. Thank you.